Okay, so now that we've got our animator all sorted and everything with our animations is working fine, we don't need to worry about that anymore. So we can just go back to our project folder so we can have that open if we need to look at some more stuff. But like we said, our player at the moment, when we're moving around in the world, is only facing one direction, which is it's not very interesting. It doesn't make a lot of sense for what our player is doing. Unless you want your player to be moonwalking around the world, we probably don't want this happening. So we're going to need to make a few very simple changes to our player script. But before we make those changes, we're just going to show an example of what we're going to do. So if we look at our player here, like I said before, we've got a position, a rotation, and a scale. And our position obviously records where we are in the world. Our rotation records which kind of way we're facing, so we could spin that around and our player will flop around like that. Not very useful, but that's okay. And we have our scale, which controls whether we're big and stuff like that. So we have all these positive numbers making our player bigger, but if we scale ourselves down to a minus value, suddenly our player gets flipped over. It's hard to tell with this sprite in particular because of the fact that it looks the exact same either way. So actually we'll just go to our art folder and we'll just change the default sprites we're using for the player here. So we'll just drag the sprite 20 here. We'll drag that into the slot for our sprite, which is attached to our player. So now he's facing to the right like that. And if we grab our scale this time and pull it in, we can see that now the player is facing to the left if we're using a minus value. So that's basically what we're going to use to control whether the player is facing left or right. So if we go into our script here, we know that we're only going to change which direction we're facing based off whether we input moving left and right. So now we can just use that to set the scale of the player and control whether he's facing left or right. So in this first one here, where we're moving to the right, we know that we want our player to be facing to the right, and by default our player already is facing to the right. So we want to make sure that if we go if we just say transform dot local scale. So as I said before, every object within Unity has a transform attached to it. So that's why rather than when we had to look for the rigid body and we had to assign it up here, when we look for transform, we don't have to look for that because every object already has that. So Unity knows if we just type in transform.local scale, what we're talking about is the transform and specifically the local scale that is on the same object that this script is attached to. So we know our player controller script is only attached to our player, so we know that it's only talking about the scale of the player here. So like I said, we know that if we're facing right, we want it to look basically like it does in the game right now. So when it's set like it looks in the game right now, we can see the scale is the X is 1, the Y is 1, and the Z is 1. So we just want it to be set to be exactly that. So we want to say transform.local scale is equal to new vector tree, and then in the bracket we want to say 1F, 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 and 1F is for one float, one float, one float. So we're saying it's a float value, not an int value. So again, we're not creating any kind of confusion between those two different values. So we'll hit our semicolon there as well. And the reason we want to make sure that we're setting this to be the default number rather than just going with it as it is because if we go and set ourselves to be facing left, then we want to be able to go back to being facing right like this. So we're going to do basically the exact same thing here now when we're facing left, which is when our horizontal axis is less than 0. And we're going to say here our transform dot local scale is equal to new vector tree again, and this time we're going to say minus 1F. So it's exactly the same size but just flipped over backwards. So we'll say minus 1F, and then again we want our Y height to be the exact same. We don't want them to be upside down or anything like that. And we want to set our Z value to be the exact same as well, because we're not messing with the Z value. As discussed before, we're working in 2D, so we just want to always keep the Z value being whatever it is by default. So it's by default it's 1 here, so we just want to leave that at 1. and not worry too much about it. So if we just save that by hitting Control and S, if we look back up here, this is why we want to make sure that we're explicitly saying this should be like this, is because if we move left first, then we're facing with our -1F, and we want to make sure we can go back to facing right by doing a +1F. So now we've saved that, and we'll go back in here. And again, it's a very straightforward and simple thing, but it makes a big difference to your game, obviously, because you want your player, whoever's playing the game, to get the direct feedback of knowing which way you're facing. So if we hit play now, with all those changes made, we can move to the right, and then we can move back to the left, and we see, just very quickly moving between them, we'll actually just right click here and maximize the screen so we can see a little bit better. But we can see our player moves around just like that, and so all our animations by default are flipped around. So we don't need to worry about making specific animations for facing different directions. Now that we've just made the whole scale of the whole player just flipped around, what that does is it means all the animations are still intact, but now our player is able to just look like he's facing in different directions. So it saves us having to make twice as many animations in a very simple way. So there you go, that's the basics of all our animations set up nicely for us. Now that we can move our player around in the world like this, we need a way to be actually able to see some more of the world, because at the moment we can run off to the side like this. So we need to make sure that our camera can start moving.